Hi, in this video we'll discuss on the topic type checking. Type checking is an important part in the analysis part of the compiler design. Now during the compilation phase, first we analyze based on the lexical analysis and then we check for the syntax analysis, and moving on we use an semantic analyzer to do an data type checking. And therefore the next topic which we'll be discussing is on type checking. Now what does type checking do? As we all know, type checking performs a semantic analysis. The main job is to check whether every arithmetic expression, every statement what we have in the program is data type compatible. Now there are two type of semantic checking. One is static, which is always done during the compilation time. Now for example, if a equal to b plus c is an expression, I should know that a is of integer type, b is of integer, c is of integer. If I could know the values and the data type which are assigned to these variables, we can always check the evaluate the type of the given expression and we during the compilation time itself, and that we call it as static type checking. Dynamic type checking happens during the runtime. Maybe we say we give some values. You say, if you say int a of 10 and you try to get in 10 values, and in between if you do enter some other variable, then you enter into a runtime error. That happens because of the dynamic checking what happens while we provide the input during the runtime. So you have two type of semantic checks, static and dynamic. Now type checking is one of the static checking operations which we always try to do during the compile time. Now when you try to define a set of rules to perform type checking, those set of rules put together is termed as the type system. So here you have a type system which helps you to assign type expressions for a part of the program. Now we should know what a type expression is. So the first terminology is type checking, where you try to check the data type of every expression and we check whether they are logically compatible. And to do that we have to define a set of rules. Those collection of rules we call it as the type system, and any system compiler which implements the type system we call it as a type checker. Now when are we going to do an type checking? We can even do it before compilation time, during the process of compilation, and after compilation, that is while you execute the program. Now if we are going to eliminate the runtime type checking as a whole and we only go for the static type checking, that is type checking during the compilation time, then we call the type system to be a sound type system. Now the programming language is said to be strongly typed if every program, when it goes through the compilation phase, the compiler will be able to execute the program without any type errors. That is, it will check for compatibility during the compilation itself, and once it passes through the compilation phase, you will never encounter any type errors. If that is so, then the programming language is said to be strongly typed. But normally that doesn't happen because we go in for generic, we try to adapt, get the input online during runtime, and so you'll have a lot of errors even which has to be clarified or reported during your execution time. Now moving on, we'll define what are the type expressions. Now what is a type expression? Every set of type expressions put together becomes a collection of rules for the type checking, and therefore a type system contains a set of type expressions. We'll move on from the basic type expression. You have three basic type expressions. The first one is all the data types what are defined in the program is termed as an basic type expression. Number two, if there is any data type mismatch, we call it as an type error, which is also an type expression. And the last one is we don't define any type at all. We define type called as void. We'll say void main of. So the function doesn't return any value, it returns an type void. So such type is also an basic type. So 3, the data types defined in the programming language, and then the error which are being given as an user friendly message to us, and the last one is no type, which we call it as void. Now any name given to this type expression is also called as a type expression. That is what you call it as a type name. The name which is used to denote any type expression is a type expression by itself. And then there are few other type expressions. Now array is a type expression. Now if you say it, if t is a type expression, then array I comma t is a type expression. Now how does it go ahead? We'll just take int a of 10. So you have two values. One is t. T denotes the integer data type. What is I? I denotes the index value. So now when I say array of I comma t, which means array of 0 to 9, that is size 10 comma integer. Now the array itself, you call it as an integer array, and therefore the type t is integer. That is what they generalize it here. When you have array I comma t, what is I? I ranges from 0 to the index value, the number of elements which you can accommodate, and then the type of the elements which can be stored inside the array. If it is an integer array, the t is going to be int. In that case, array of I comma t will be t, where this array I will be an integer value. Now you have to go ahead with Cartesian products. You take two matrices, for example, or any vector, for example. So if you have two different types, T1 and T2. T1 will be the type for matrix 1. T2 would be the type for matrix 2. Or T1 is the type for vector 1. T2 is the type for vector 2. And when we try to multiply it, you find the Cartesian product. So it is T1 into T2. And pointer itself is a type expression. Pointer of t is a type expression. And then you have functions. Now functions, you have two things. One is called the domain and the other one is called the range. Suppose you have int add of int comma int a comma int b. Now what is happening? You are taking two integer values, doing some manipulation and finding the sum of two integer and returning back a single integer value. So you are mapping 1 to 2 values. So you have the range as 2 plus 3. So you have 2 as one set, 3 as another range value, and we try to add it. You have a domain value as 5. So now what happens? Here you have a domain type and a range type. So you say that int produces int, because you have take only one parameter. You can take any number of parameters. In that case, int produces int star int will be the answer. Now for the example what we were discussing a little before, that is int add is of int a comma int b. The function would be int produces int cross int, because the first parameter what you passed in was in, the second parameter what you have passed in was in, and what we produce is also an int. So all these are the various type expressions which are allowed. Now moving on to how we identify or define type checking in your productions, which means how do I express the type checking concept while we write context free grammar. So you add a semantic rule. When you add a semantic rule, it becomes a syntax directed definition. So we'll see how things are. Here you have an ID which we have which can be reduced to an expression E. So here E represents the expression as a whole or some sub expressions. So now you have an identifier which they call it as a valid expression. Now when you have an identifier, where do I get the data type of the identifier from? Whenever we have an identifier, during our lexical analysis phase, we try to store the data type in the symbol table. So we have a lookup command which returns the data type of the identifier, which is stored in an E's attribute which is termed as type. So E.type will have the data type of the identifier. Now these three are declarative statements. So you have character, space literals, integers, set of literals, real and set of literals. If this is the case, we are directly assigning is type for this declarative statement to be character. So E dot type is character. Here it is E dot type is int and E dot type is real. Now we'll just take an example of adding two numbers. We'll just see how we can add two numbers. When you have an integer and an integer, the output would be an integer. If it is integer and real or real and integer, the output has to be a real. If it is both real, you have the output as real. That is what we are checking here. You have all the four options because it produces only numerical addition. You can do only with numbers, not with characters. So you say if E1 type is int and E2 type is int, then the return would be an integer data type. And else if the first part is int, maybe it is 2 and this is 3.0, then your type would be real, the longer one, the one with which has the longer range. So E1 dot type is real and E2 is int. Here what we have is a real. And E1 both are real, the output type is also real. Now what happens if there is any other data type which is been fed in? Maybe for example here we have taken three data types. Suppose if you have E1 dot type is equal to character, that doesn't fit into any one of these first four conditions. In that case, E dot type will return a type error. That is where we'll have errors which say that there is a mismatch in type. You cannot add a character with a numerical number and so on and so forth. So how do we produce it? It is all because of these type expressions. Now we have type checking for statements. Now what we really have here, we have many statements such as control statements, we have switch cases, so on and so forth. Now for our understanding, we'll take if then else statement and also a while statement. Now we'll go for an if then else statement. Now how have they defined it? We have a condition. Now that condition may be, for example, A less than B, A greater than B, so on and so forth. So that condition we have defined it as an expression. So this is a relational condition. So when I say A greater than B, that relational expression would return a Boolean data type. If this is true, then what are we going to do? If this is going to define something called as Boolean, then you have a set of statements here. The data type of that set of statement would be reflected to yes. Now if that is the case, how are we going to do it? For example, I would like to type here saying if A is less than B, then A is equal to A plus plus, or we'll just have it as A plus B. Okay, so this is an expression taken for our easy understanding. Now what is this? A less than B is an conditional expression which gives me either yes or true or false. If it is true or false, it's going to be of Boolean data type. So you say E dot type is equal to Boolean. If this is the case, then I have only one statement to be executed. So now what do I say? Based on our previous explanation, you take A to be of integer, B to be of integer. So what is when I reduce it, what has to be the type of A? A's value has to be of integer. So this becomes your S1 type. This is statement S1. So this S1 type is assigned to S type, the statement. When you reduce it, it gets assigned to the S type. Else you go and reflect an error for it. So that is how we try to define it. Now similarly, we go in for the while condition. While again has a conditional statement. We can say while A less than B, you do the set of statements repeatedly. So now every time you check whether it is of Boolean data type. If it is of Boolean data type, then S1's type is assigned here. Now you might ask me a question saying that in the then part or in the do part, you will have not only one statement, but you will have a set of statements. So when I have a set of statements, every statement will be evaluated, put together, and if some statement counts an error, the S type would be an error. we'll say S1, S2, S3, and then if S1 will be an error or else it will not be so. So coming again, when I say A plus B, you have an expression. Now this expression here, it is an assignment statement. ID is equal to E, so which I reduce it to an statement. S stands for statement. So if ID type is equal to E type, that is A is equal to A plus B. You say A plus B, you have taken it as integer. And then A's type is also integer. So if the ID type is equal to the expression type, then the statement type returns to be void. You don't say anything. It's correct. The complete expression is correct and you don't return any type to it. Else we return an type error. So this is how we try to evaluate these expressions, sorry, the data type of every expression. Let it be a control statement, let it be an arithmetic expression, let it be an if then statement, so on and so forth. This is how we try to check every data type of every variable what is passed in the expression. So with this we come to an end of the type checking concept. Thank you.